Good evening, everyone. Let me revise with whatever we had done in the last class. In the last class, we studied the rules of differentiation. The first six rules I had discussed, the seventh one and eighth one, I'm going to discuss today. The first rule of differentiation is constant rule. Differentiation of a constant is going to be equal to 0. If I take an example of the same, let me take the example of the same. If I have y is equal to 10, then I can write dy by dx is going to be equal to 0, as y is equal to 10 and 10 is a constant. Similarly, if I have f of x is equal to 1234, f dash of x, which is going to be the differential of the function f of x, or I can write this as dy by dx is going to be equal to 0, because 1234 is a constant. This will be your first. The second rule is constant multiple rule. What does it say? It says that the differentiation of a constant and a function is going to be a constant and the differential of that function. I think Aditya is here. Let me just let him in. Yes. So let me take one of the example again. So I can take for the second one. If y is equal to 10x square, or let me take 10x, okay, then the value of dy by dx is going to be 10, the constant, multiplied by the differential of x, the function whatever we have. Differential of x is going to be x raised to the power 1 minus 1, right? It is going to be x to the power 0, which is going to be 1. I can write dy by dx as 10. This is going to be your second. The third rule we discussed was power. Differential of x raised to the power n is given by nx n minus 1. I can take the example for this as if y is equal to x raised to the power 6. dy by dx is given by the formula nx n minus 1. Substituting the same for this particular value, here the value of n is equal to 6, dy by dx is going to be n, which is 6, x n minus 1, which is going to be 6x 6 minus 1. The answer is going to be 6x raised to the power 5. 6x to the power 5 is going to be the differential of the function y is equal to x to the power 6. Let me take one more example. If y is equal to x raised to the power 15, again I can use the same formula. Dy by dx is going to be nxn minus 1, where n is equal to 15. Substituting the same, I will be getting 15 x raised to the power 15 minus 1. The value of dy by dx is going to be 15 x raised to the power 14. Similarly, I can even have negative values of x as well. If x is raised to the power minus 3, now I can use the same formula. Dy by dx is going to be equal to n x n minus 1. This is the power rule. Here n is going to be minus 3. Now dy by dx is going to be minus 3 x raised to the power minus 3 to the minus 3 minus 1. The answer I am going to get dy by dx as minus 3 x raised to the power minus 4. It can be written this way, or you can take x raised to the power minus 4 to the denominator, and you can write dy by dx as minus 3 over x raised to the power plus 4. Both are one and the same. So the power rule is applicable when you have a whole number, whole positive number, or a negative number as well. So for any integer, it is applicable. Even for decimal also it is applicable. If you have to find out, say y is equal to root x, root x can be written as x raised to the power 1 over 2. Use the same formula. Dy by dx is going to be n x n minus 1. Here n is going to be half, so dy by dx can be written as 1 over 2 x raised to the power 1 over 2 minus 1. This is going to be 1 over 2 x raised to the power minus 1 over 2. This can be written as 1 over 2 x raised to the power plus 1 over 2 x to the power 1 over 2 can be written as root x. So the answer dy by dx is going to be 1 over 2 root x when you have y is equal to root x. This was your power formula. Next, we discussed sum rule. Whenever two functions are added together or subtracted together, I can take sum and difference rule both in the same way, right? Because both are one and the same. If we have sum of two functions and or the difference of two function, the differential of that is going to be just the differentiation of one independent function added with the differential of the other independent function. Let me take one more example so that it will be clear for you. If I have the fourth one, y is equal to x squared plus sine x. Now, the differential of y with respect to x is going to be the differential of x square first plus the differential of sine x. The differential of x square can be found out using the power formula. It is going to be 2x 2 minus 1, and the differential of sine x is going to be cos x. I can write dy by dx as 2x plus cos x. Similarly, if I have a negative sign, say if I had y is equal to x square minus sine x. Now the differential of y with respect to x dy by dx is going to be the same thing but with a negative sign. This is the only difference. Okay, so this one is your sum rule. This is your difference. Next, we discussed quotient rule, or you can call, okay, we discussed the product rule, right? The product rule says that if we have the product of any two functions, the differential of that product is going to be the first function multiplied by the differential of the second function plus the second function multiplied by the differential of first function. Either I can write it this way as given here. So let me, yes, you can either write it this way or you can write it as functions u and v as well. If y is equal to uv, meaning that if y is a product of two functions u and v, then the differential of y with respect to x is given by the first function multiplied by the differential of the second function plus the differential of the first function multiplied by the second function. This is the formula of product rule. Let me take one of the example. Say if we have y is equal to x squared multiplied by sine x. X square is multiplied by sine x. Now I can write y is equal to u multiplied by v, because my question is in the form of two functions multiplied to each other. So I can take one of the function as u, another function as v. U can be equal to x square, you can be equal to x square. V is going to be equal to sine x. V is going to be equal to sine x. If u is equal to x square, u dash is going to be the differential of x square. What is the differential of x square? It is 2x, 2 minus 1, it is going to be 2x. Similarly, v dash is going to be the differential of sine x. The differential of sine x is cos x. I can use the product rule which says that dy by dx is going to be equal to the first function u, which is going to be x square, multiplied by v dash, which is going to be the differential of the second function, which is cos x, plus u dash, which is the differential of the first function, it is going to be 2x, multiplied by the second function, which is going to be sine x. Dy by dx can be written as x square multiplied by cos x plus 2x multiplied by sine x. You can take one of the x as common and you can write dy by dx as x multiplied by x cos x plus 2 sine x. This is going to be your final answer when you consider the product. Is that clear? Yes? Now, let me just discuss few of the formula of basic differentials. Then let me go to the next two. We have differential of trigonometric functions. You have to by heart all of the differentials. The differential of sine x is going to be cos x. The differential of cos x is minus sine x. The differential of tan x is secant square. The differential of cot is minus cosecant square x. The differential of secant x is going to be secant x tan x. The differential of cosecant x is going to be minus cosecant x cot x. Next, we have differential of log and exponential function. If you differentiate e to the power x, it will remain as e to the power x itself. If you differentiate log of x, you can write ln of x or log x. If you differentiate log x, you will be getting the answer as 1 over x. Similarly, if you differentiate a to the power x, where a is a constant, then the differential of a raised to the power x is going to be given by a raised to the power x multiplied by log a. Similarly, if we have x raised to the power x, the differential is going to be x raised to the power x multiplied by 1 plus log x. The differential of log x raised to the base a is going to be 1 over x multiplied by log of a. Okay. Now, let me go to the product rule again. I'll be taking one more problem. Then I will be going to the quotient rule. And then subsequently to the chain rule. Let me take out this one. Make some space. Yes. Okay. So let me take one more problem. Say y is equal to e to the power x multiplied by log of x. I observe that in this problem, two functions are multiplied with each other. So I can use my product rule. What does the product rule say? Product rule says that if y is equal to u multiplied by v, meaning that two functions are multiplied with each other, then dy by dx is going to be u v dash plus vu dash v, where u dash and v dash are differentials of u and v respectively. Now, here I can consider u equal to e power x and v is equal to log of x. U dash is going to be the differential of e power x. I told you the differential of e power x is going to be e power x itself. It is not going to change. V dash is going to be the differential of v. The differential of log x is going to be 1 over x. You have the value of u, v, u dash and v dash. Substitute the same thing in the product formula or the product rule. Dy by dx is going to be u multiplied by v dash. U is e power x multiplied by v dash. V dash is 1 over x. Plus, sorry, I should be taking plus sign. Plus u dash. U dash is going to be e power x multiplied by v. V is going to be log of x. When I simplify, I'm going to get dy by dx e power x is common, and here it is going to be 1 plus x, plus here it is going to be log x. This is going to be your final answer for the differential of y. If y is given as e power x multiplied by log x. Next, let me discuss the quotient rule. The quotient rule says that if we have two functions which are divided, if we have a function in the numerator and if I have a function in the denominator, then the differential of that function is going to be the second function multiplied by the differential of the first function minus the first function multiplied by the differential of the second function divided by the second function whole square. So let me write it in the form of u and v, so it is going to be easier. If I have y as u multiplied by v, sorry, u divided by v in this form, then quotient rule says that the differential of y with respect to x is given by the denominator, the function in the denominator, which is going to be v multiplied by u dash minus u multiplied by v dash divided by v square. This is going to be your quotient. You can either represent it by u and v, or you can represent it as f of x and g of x also, as it is given over here. Yes. Now let me take one of the example from quotient rule. Yes, this is was the quotient rule. Now here let me take one of the example. Say y is equal to sine x divided by x squared. You have to find dy by dx of y. Okay, so I can start by writing y can be represented as u divided by v, u divided by v, where u is equal to sine x and v is equal to x squared. I have the value of u, I have the value of v. I can find out the value of u dash. U dash is the differential of u. U is equal to sine x. The differential of sine x is going to be cos x. Yes. I have the value of v. The differential of v dash is going to be the differential of x squared. It is going to be 2x. I have the value of u dash, v and v dash. I can substitute the same in this formula. Dy by dx is going to be equal to v multiplied by u dash. V is going to be x squared multiplied by u dash. U dash is going to be cos x minus u, which is going to be sin x, multiplied by v dash, which is going to be 2x whole divided by v square. V is x squared whole to the power 2. Upon simplifying, I will be getting dy by dx as x squared multiplied by cos x minus 2x multiplied by sine x divided by x raised to the power 4. Upon simplifying further, I will be getting dy by dx as cos x, or I can write x cos x minus 2 sine x divided by x raised to the power. Further, if you want to simplify, even you can write this as dy by dx is going to be cos x divided by x squared minus 2 sine x divided by x cube. Depending upon the options, if it is given in MCQ question, you can simplify it further. So this is how you are going to solve using the quotient rule. Let me take one more example using the quotient rule, so it is going to be clear. Y is going to be log x divided by, say, cos x. This is going to be your question. I can write y is equal to u divided by v, where u is going to be equal to log x and v is going to be equal to cos x. If I know what is u, u dash is going to be the differential of log x, which is going to be 1 over x. Similarly, I can take the differential of v as v dash, which is going to be minus sine x. I can write my quotient rule. From the quotient rule, dy by dx. If two functions are divided such as u and v, then the formula is v u dash minus u v dash divided by v squared. I have all the values. Upon substituting, I will be getting the answer dy by dx as v multiplied by u dash, v is going to be cos x, multiplied by u dash, which is going to be 1 over x, minus u, which is going to be log x, multiplied by v dash, which is going to be minus sine x, whole divided by v square. V is going to be cos x whole square. Upon simplifying, I will be getting the answer as dy by dx is going to be cos x divided by x, minus into minus is going to be plus sin x multiplied by log of x whole divided by cos square x. This is going to be your final answer. Further, also you can simplify this as dy by dx. I can write this as dy by dx is going to be equal to 1 divided by x cos x plus sin x multiplied by log x divided by cos square x. Even this way, you can simplify the answer. So this was your quotient rule. Lastly, we have chain. Now, if a function is given inside a function, then we can use chain rule. Let me show the same thing. Let me take an example, or let me write. Is someone there? I got a notification. Let me just check. No, okay. Yeah. Let me write the chain rule formula over here. If y is equal to, say, sine of x squared, okay, now we observe that here it is a function inside a function, right? So y is depending upon x squared, also sine x, it is also going to be divided depending upon sine x, right? So we have a function inside a function. Now, how to use the chain rule, right? We already know if y is equal to sine x, right, the differential y dash or dy by dx is given as cos x. This is very very simple because now it is just x, right? Now how do we solve if we have 2x or x squared? Okay, we can use our chain rule. So what does our chain rule says? Basically, we have to find out dy by dx, right? So here I can write dy by dx as dy by dx as dy by dA multiplied by dA divided by dx. Now, when I cancel this out, when I cancel dA and dA, will I be getting the value of dy by dx? Yes. So I will be using the chain rule. So first step, what I'm going to do is whatever the question is given. So it is given as y is equal to x square. I will extend that by writing y is equal to, I'll introduce a variable which is a. Y is equal to sine a. Can I write y is equal to sine x square, sine of x squared as y is equal to a, and right, a is equal to x squared? Yes, same thing, right? Now dy by dA, meaning that the differential of y with respect to a, what is it going to be? The differential of y with respect to x when y is equal to sine x, it is cos x. So differential of y with respect to a is going to be cos a. Similarly, if a is equal to x square, the differential of a with respect to x, dA by dx is going to be the differential of x square. What is the differential of x squared? It is going to be 2x. Right? I have the value of dy by dA. I have the value of dA by dx. I can find out the value of dy by dx. The value of dy by dx is going to be dy by dA, which is going to be cos a, multiplied by dA divided by dx, which is going to be 2x. The answer is going to be 2x multiplied by cos a. But what is the value of a? A is x squared. So I can write dy by dx as 2x multiplied by cos x squared. This is going to be the differential of y is equal to sine x square. Let me take one more example. If we have y is equal to sine 2x instead of sine x, we already know if y is equal to sine x, then the differential y dash is going to be cos x, or you can write dy by dx. The differential of y with respect to x is going to be cos x. This is a standard formula. How do we solve if we have y is equal to sine of 2x? Now it is not just x, we have 2x. We can use the chain rule. To use the chain rule, I can write consider or let, anything you can write, a is equal to 2x. When a is taken as 2x, y can be written as sine of a. I have the value of y, I have the value of a. I can find out y dash or dy by dx, the differential of y with respect to x. If y is equal to sine a, the differential of y with respect to a, sorry, dy by dA is going to be cos a. I have found out the value of dy by dA. Similarly, if a is equal to 2x, dA by dx, the differential of a with respect to x is going to be the differential of 2x. What is going to be the differential of 2x? It is going to be just 2. From the chain rule, I can write dy by dx is going to be dy by dA multiplied by dA multiplied divided by dx. Upon substituting, dy by dx is going to be dy by dA, which is cos a, multiplied by dA by dx, which is going to be equal to 2. The value of a I have taken as 2x. I can substitute the same over here. Dy by dx is going to be 2 multiplied by cos a. A is 2x. The answer is going to be 2 cos 2x. So the differential of y is equal to sine 2x is going to be 2 cos 2x. This is how you will be using the chain rule.